Welcome back everyone to this lecture on categorical plots. We're first going to understand statistical estimation within categories. So in part one, we're just going to work on understanding the plots and when to use them, and then in part two, we'll actually code them out with Seaborn. So the categorical plots discussed here are going to focus on displaying a statistical metric per category. For example, what's the mean value per category? Or count the number of rows per category. And what I like to think of this as is the visualization equivalent of a group by call. There are two main types of plots for this, and they are count plot, which simply counts the number of rows per category. Same thing as doing a group by and then calling .count on this. It's just the visualization equivalent of that. And then the bar plot is actually a general form, which actually allows you to choose any metric per the category. So you can decide to show the mean per category or the standard deviation per category, or even both. So let's actually look at some examples here. Here we have the count plots coming first. The count plot here is shown for the corporate divisions. So essentially what this is reporting back, on the y-axis we have the number of rows, so the total counts of instances, and then on the x-axis we have the corporate divisions. So if we look at this plot, we can immediately see that the computer software division has the least number of instances within our entire data frame, and that more or less printers, peripherals, and office supplies divisions are all around the same number of instances. Now, something to keep in mind is if you create a count plot for categories that have major differences as far as the counts of instances between them, sometimes those very low counts may be a little unclear. So just looking at this plot, it almost looks like we only have just like 1 or 2 master's degrees, but it's really hard to tell just because of the scale. Notice that we have so many instances of some college and associate's degrees that suddenly it becomes a lot harder to actually make out how many counts we have of master's degrees. I can here see the relative counts per each quite clearly, so that's something that's good with the count plot. But if somebody were to ask you, directly reading off this plot, how many people have a master's degree in the data set, that's really hard to answer here. And in that case, you probably just want to report it back as a table with group by .count. Now what's nice about count plot though is we can actually add an additional hue separation to show more than just one category. So now what I'm showing here is the count per level of education, and then within that level of education I'm further dividing it up into the training level. So now let's talk about the bar plot, which is the general form that allows you to choose any measure or estimator for the y-axis. And what you end up doing is inside of that Seaborn plot call, you will actually pass in the NumPy estimator function, which is numpy.mean or numpy.standard deviation, etc. And so for example, what we can do here is I can actually plot out the mean value and standard deviation per category instead of just a count. Now before we actually show you this plot, I want to tell you a very important note here, is that you should be really careful when you're doing something like a standard bar plot for displaying a mean or a standard deviation. Because the bar is filled and continuous, a viewer may interpret continuity along the y-axis, which may or may not be correct. So you should always make sure to add additional labeling and explanation for these sort of plots. Be very careful with just a general bar plot. It's showing filled continuity along the y-axis, which could be misleading. So what do I actually mean by that? Here, I am showing a bar plot. However, what I'm actually showing along the y-axis is the salary. So you may be asking yourself, what does the height of the bar represent? And in this case, the height of the bar itself represents the average salary value. And then the black line on top of that bar represents the standard deviation. So what can I see here visually? Well, visually, I can see that the master's degree has the least standard deviation versus the rest of these levels of education. So that's something important that we can see. I can also see that it looks like high school level of education has the lowest average salary. However, note here that the color bar is filled from 0 all the way to the average salary. Whether or not that makes sense is a good question. So, if someone were to ask you, what is the average salary per level of education, is this best actually shown with a bar plot? And in my opinion, it is not. I think since these are just single values, you should probably just report this back as a table. If somebody's asking you, give me the average salary and standard deviation per level of education, instead of showing them this plot, it might be clearer just to show them the actual table instead. Here again, I can see the same information. I can clearly see that high school is the lowest average here, and then I can also see that master's degree has a significantly lower standard deviation than the other levels of education. And what's also nice here is I can do a really nice comparison between the means really easily off these numbers versus off of the bar plot. Since all the bars were quite close together, it may have been unclear. So in this particular case, I would report this back as a simple table instead of visualizations. Recall that the purpose of a visualization is to make digesting the information easier on the viewer, not harder. Okay, so let's explore coding these plots out with Seaborn in the next lecture. I'll see you there.